And finally tonight in the future of everything, I don't know about you, but I spent the weekend refreshing for updates on our favorite interstellar visitor, that comet or question mark 3I Atlas. It is up to a little bit more strange.
3 minutes ago, automated sky surveys tracking the outer frontier of our solar system detected a subtle but undeniable deviation in the trajectory of the interstellar object known as 3I/Atlas. And at first, the anomaly was small enough that most systems flagged it as a calibration irregularity rather than a discovery. 3I/Atlas had already become one of the most discussed astronomical events of the decade because it represented only the third confirmed interstellar object ever observed passing through our solar system. A visitor from another star carrying with it chemical signatures forged in an entirely different cosmic environment. Its path was hyperbolic, meaning it was not gravitationally bound to the sun and would not settle into orbit. It was merely passing through, a wanderer crossing our celestial neighborhood before vanishing back into interstellar darkness. For weeks, astronomers had been carefully refining its speed, spin rate, and spectral composition. Early data suggested a mixture of volatile ices and rocky material, with a rotation period that caused predictable brightness fluctuations as it tumbled through space. Nothing about it initially suggested danger. It was distant, fast, and scientifically invaluable. Then, the deviation appeared. At first, it measured as a fractional shift in velocity, too smooth to be explained by simple outgassing and too consistent to be dismissed as noise. Within minutes, independent observatories in Hawaii, Chile, and the Canary Islands confirmed the same subtle acceleration. The object was changing speed in a way that did not align with standard cometary physics. As recalculations spread through internal networks, infrared telescopes scanning the region behind 3I/Atlas detected a faint thermal irregularity. It was not visible in optical wavelengths and did not reflect sunlight in any meaningful way, but it exerted a gravitational influence that became clearer with each new data set. Something massive was trailing the interstellar object on a nearly identical vector. The probability of two unrelated interstellar bodies entering our solar system along matching trajectories at roughly the same time was astronomically small. Yet the evidence accumulated in real time as astrometric measurements tightened and background stars shifted subtly under the influence of an unseen mass. Preliminary size estimates stunned researchers. Based on gravitational perturbation alone, the trailing object appeared to be nearly 100 times larger in diameter than 3I/Atlas. Even accounting for uncertainty margins, the mass differential was extreme. More puzzling still was its albedo, or rather the lack of it. The object absorbed light with unusual efficiency, reflecting almost nothing back toward our instruments. In deep field imagery, it appeared not as a bright intruder, but as an absence, a distortion against the star field detectable primarily through motion and gravitational lensing. Its thermal profile suggested internal energy, yet not at levels consistent with a star or even a typical brown dwarf. It existed in a category that did not neatly match known classifications. Trajectory modeling intensified the mystery. Rather than drifting independently, the larger object mirrored the path of 3I/Atlas with increasing precision. It was not merely following, it was gradually closing the distance. The acceleration was minute but measurable, and the smoothing algorithms used to filter out observational error could not eliminate it. In private communication channels, researchers debated whether gravitational capture scenarios could explain the behavior, but the geometry did not fit. Neither object was bound to the sun in a way that would produce this alignment naturally. If anything, both appeared to be responding primarily to each other. As hours passed and more telescopes joined the observation campaign, spectrographic analysis of 3I/Atlas revealed new irregularities. Its brightness curve began to fluctuate beyond what rotation alone could justify. Small fragments seemed to shear off its surface, leaving faint trails that dissipated rapidly into vacuum. Some suggested tidal stress from the larger mass, but tidal forces at the measured distance should not have been strong enough to produce such fragmentation. Then instruments recorded a narrow spike in infrared radiation originating from the region between the two objects. The pulse was brief and highly directional, lasting less than a second, yet it repeated across independent detectors separated by continents. The possibility of instrument malfunction was considered and quickly ruled out. Calibration checks confirmed consistency. Amateur astronomers monitoring publicly available orbital data began to notice unexplained adjustments in 3I/Atlas's projected path. Online forums lit up with speculation, though official agencies maintained cautious language, describing the situation as routine monitoring of dynamic interstellar bodies. Behind closed doors, however, discussions grew more urgent. Planetary defense teams ran impact simulations, confirming that neither object posed a direct threat to Earth, but the unusual interaction warranted close scrutiny. As the larger mass continued its measured approach, updated density estimates complicated the picture further. The object appeared extraordinarily compact relative to its size, yet it did not produce the gravitational lensing strength expected from a black hole of comparable mass, nor did it emit radio signatures typical of neutron stars or pulsars. Its energy output was low but structured, not chaotic. Each intermittent pulse directed toward 3I/Atlas coincided with additional fragmentation of the smaller object. High-resolution spectroscopy detected heavy metals and complex organic molecules vaporizing and dispersing in controlled arcs rather than random sprays. Angular momentum readings added another layer of unease. 3I/Atlas's rotation rate began to slow incrementally. The change was subtle but unmistakable, indicating that torque was being applied externally. In the vacuum of space, absent significant collision or outgassing, rotational deceleration of that magnitude required interaction. Whether gravitational resonance or something less understood, the effect was measurable. Observatories extended observation windows, redirecting time from other scheduled research to capture every available photon from the event. The distance between the two objects continued to shrink, though still vast by human standards. Data visualizations rendered them as luminous points in simulation software, one dwarfing the other, both racing through the outer solar system at extraordinary speed. A second, stronger infrared pulse erupted, and immediately afterward, 3I/Atlas's luminosity dropped sharply. Its estimated mass decreased in updated models as more material appeared to break free. The larger object's trajectory adjusted minutely in response, maintaining optimal alignment. Theoretical explanations multiplied. Some researchers proposed a rare gravitational shepherding phenomenon, akin to how massive planets influence smaller bodies within rings, though the scale and interstellar context were unprecedented. Others explored the possibility of a primordial dark matter clump interacting via unknown mechanisms, yet no model fully accounted for the structured energy emissions. A handful of voices cautiously entertained artificial origins, not as a conclusion, but as a mathematical placeholder for unexplained agency. Those suggestions remained speculative and controversial, yet the data did not comfortably settle into known astrophysical categories. As both objects advanced toward the inner solar system, though still well beyond the orbit of Neptune, particle detectors registered faint streams of energized matter linking the two masses intermittently. These streams were not continuous beams, but short-lived bridges, like electrical discharges flickering across unimaginable distances. Each occurrence corresponded with further reduction in 3I/Atlas's mass estimate. The smaller object's once robust spectral signature faded, replaced by sporadic bursts as material stripped away. Government observatories increased coordination, and military-grade satellites contributed higher sensitivity imaging. Public statements emphasized that no impact risk existed, a fact supported by trajectory simulations. Yet internal memoranda acknowledged that humanity might be witnessing a form of interstellar interaction never before documented. The notion that two objects from beyond our solar system could enter together, one trailing the other, challenged assumptions about randomness in cosmic encounters. Over the following observation cycle, the gap between the objects narrowed to its minimum recorded distance. Telescopes captured a complex radiation spike more intense than prior pulses. 3I/Atlas flared briefly, then dimmed to nearly half its former brightness. Its rotation slowed further, and debris clouds expanded before dispersing. The larger mass stabilized its course as though completing a calculated maneuver. Within hours, the smaller object's once distinct spectral fingerprint weakened dramatically. Then, as abruptly as it had accelerated, the massive object altered its vector. Rather than continuing inward toward the sun, it shifted onto a trajectory that would carry it back toward interstellar space. The adjustment was deliberate and smooth, not chaotic. 3I/Atlas, diminished and fragmenting, continued along a shallower path toward the inner solar system, now little more than a remnant of the robust traveler first detected weeks earlier. By the time dawn reached major observatories, the larger object's separation increased steadily. Its thermal signature receded, blending gradually into background cosmic noise. What remained of 3I/Atlas offered scientists a final opportunity for analysis as it drifted inward, shedding faint traces of the encounter. No collision had occurred, no catastrophic explosion illuminated the sky, yet the interaction had fundamentally altered the smaller body's structure and trajectory. In the aftermath, research teams compiled terabytes of data for years of analysis. Papers would debate gravitational resonance, exotic matter hypotheses, and measurement uncertainties. Skeptics would challenge interpretations, and new simulations would attempt to replicate the observed behavior using known physics. Yet one fact persisted beyond theoretical framing. Two interstellar objects had entered our solar system along nearly identical paths, and one had measurably influenced, diminished, and then departed from the other in a sequence of events that unfolded under humanity's watchful instruments. The sky above Earth remained outwardly unchanged, stars steady and silent, but the perception of emptiness felt thinner. Interstellar space, once imagined as a vast and passive expanse between stellar systems, had revealed dynamic complexity. Whether the interaction was a rare natural phenomenon or something that would demand entirely new categories of understanding, it demonstrated that the void is not merely a backdrop, but an active arena. Somewhere beyond the orbit of Neptune and moving steadily outward, the gigantic dark traveler continued its journey between the stars, carrying with it whatever material or momentum it had acquired. It neither signaled nor threatened, neither approached Earth nor lingered for observation beyond necessity. It arrived, interacted, and departed with quiet precision. Humanity, for the first time, may have witnessed not just a visitor from another star, but an encounter between wanderers in the vast ocean of space, an event that challenges the assumption that interstellar objects travel alone and untouched across eternity. Even as the massive object retreated into the darkness beyond Neptune, its influence lingered in the fragments of 3I/Atlas. Each shard carried subtle anomalies in composition, isotopes and elements that did not match anything observed in our solar system. Scientists analyzed these fragments obsessively, hoping to uncover what had occurred during the encounter. Every measurement confirmed something extraordinary. 3I/Atlas had not simply passed through space. It had been altered, stripped of mass, and nudged along a trajectory that seemed almost purposeful. Simulations ran around the clock. Supercomputers struggled to reconcile the small but consistent deviations in speed and rotation with known physics. Gravity, solar pressure, and tidal forces accounted for part of the effect, but not all. Something else had acted. Some researchers whispered the term agency, though cautiously. The data was real, measurable, but the explanation remained beyond established theory. Amateur astronomers continued to track the remnants of 3I/Atlas. Despite its diminished size and brightness, it moved predictably, still carrying signatures of the larger object's passing. Each observation confirmed what professionals had seen. This was not a random interstellar encounter. The universe had orchestrated a meeting between two objects across light years, one enormous, one small, each following a path that hinted at purpose or interaction far beyond human understanding. Within the scientific community, debate intensified. Could this be a natural phenomenon previously unseen? Was the larger object a type of dark matter cluster, a primordial fragment, or a relic from a long-extinct star system? Or, more controversially, could it be artificial? None of the hypotheses could fully explain the precise acceleration, the structured energy pulses, or the apparent interception. As weeks passed, data continued to flow. New models suggested the larger object had exerted forces capable of manipulating 3I/Atlas without direct contact. Particle emissions, radiation spikes, and the shifting rotation all pointed to interactions that had never been observed before. Every metric added weight to a single, undeniable fact. Humanity had witnessed an interstellar encounter unlike anything in recorded history. Astronomers speculated about what might have happened before either object entered the solar system. Had they been traveling together for centuries? Millennia? Were these objects part of a larger structure, or isolated wanderers whose meeting was a cosmic coincidence? The more data poured in, the more the encounter challenged assumptions about the randomness of interstellar space. Despite its retreat, the larger object left a permanent mark on human knowledge. It proved that space was not passive, that objects could interact in ways previously unimagined. And for the fragments of 3I/Atlas still moving inward, the journey continued, carrying evidence of a moment when the universe revealed itself to be far more complex, far more deliberate, and far more astonishing than humanity had ever dared to imagine. The remnants of 3I/Atlas continued their slow drift toward the inner solar system, faint and diminished, but still detectable by even modest observatories. Every photon collected from those fragments carried a story of the encounter, a chemical and physical record of forces that had acted over unimaginable distances. Spectrographs detected elements arranged in patterns unlike any naturally occurring asteroid or comet. evidence that some process, whether gravitational, energetic, or otherwise, had fundamentally altered the body. Scientists describe the event in hushed tones as a cosmic interaction, a phrase chosen carefully to acknowledge the extraordinary without leaping to conclusions. Even as researchers parsed the data, the larger object became increasingly distant, receding toward interstellar space with a velocity that would soon remove it from human observation entirely. Its retreat was not chaotic. It maintained a precise vector, seemingly unconcerned with the sun or the planets, yet perfectly aligned to ensure 3I/Atlas had been influenced as intended. The vast gulf of space between the two bodies made it impossible to determine whether the larger mass acted by design, instinct, or some natural process beyond our comprehension. Observatories across the world continued to monitor the fading fragments. Each measurement reinforced the anomaly. 3I/Atlas had lost mass in a structured way. Its spin rate had altered, and particles ejected from its surface followed trajectories consistent with directed forces rather than random dispersal. Mathematical models attempted to replicate the event, testing every conceivable combination of gravity, radiation pressure, and material outgassing. None could fully account for the observed outcomes. Amateur astronomers documented the fragment's slow migration, contributing valuable data to professional teams. Social media and online forums buzzed with speculation, though official statements remained cautious, emphasizing the absence of threat to Earth. Yet the underlying truth was clear to those studying the phenomenon. Humanity had observed an interstellar event unlike any before, one that challenged fundamental assumptions about how objects travel and interact across the cosmos. Weeks of observation revealed additional surprises. Infrared readings of the larger object, though faint, indicated periodic emissions that were not consistent with natural stellar or planetary bodies. The pulses occurred at irregular intervals, subtly aligned with the positions of 3I/Atlas fragments during their inward journey. The phenomenon was fleeting, detectable only by the most sensitive instruments, but the pattern suggested an interaction that extended across light minutes of space. As data analysis continued, theoretical discussions within the scientific community grew increasingly intense. Some posited that this could be a type of previously unknown interstellar phenomenon, a natural mechanism that allows massive objects to influence smaller ones at a distance through exotic fields or forces. Others speculated about an entirely artificial cause, though no evidence of technology or construction could be observed directly. Every hypothesis was constrained by the same unyielding data. Two objects from interstellar space had met, one had affected the other in measurable ways, and the larger body had then departed with precision. The public, largely unaware of the full extent of the encounter, remained fascinated by reports of unusual interstellar activity. Science communicators emphasized the rarity of detecting interstellar objects at all, let alone witnessing one interact with another. For researchers, the event became a focal point for collaboration across nations, observatories, and disciplines. Teams specializing in orbital mechanics, spectroscopy, astrophysics, and particle physics pooled their expertise to interpret the anomaly. Ultimately, the encounter of 3I/Atlas and the massive trailing object expanded humanity's understanding of interstellar dynamics. The event demonstrated that the void between stars is not as empty as it appears, that interactions can occur over light years, and that massive, dark bodies may influence smaller ones in ways we have only begun to comprehend. The fragments of 3I/Atlas, traveling inward, carried evidence of forces that are not yet fully understood, but each measurement brought humanity closer to grasping the complexity and subtlety of cosmic motion. Even as the larger object vanished beyond observational reach, its brief passage had left an indelible mark. Scientists reflected on the implications. Interstellar space is not merely a passive expanse, but an arena in which massive bodies can interact across extraordinary distances, sometimes in ways that suggest precision or intent. For the fragments of 3I/Atlas, and for the observers on Earth, the universe had revealed a hidden dimension of motion, energy, and interaction, leaving humanity with a profound reminder that the cosmos is far more intricate and astonishing than we have ever imagined. The fragments of 3I/Atlas continued their passage through the solar system, fading but leaving a trail of data that would occupy astronomers for years to come. Each new observation revealed subtleties in motion and composition that suggested the encounter had fundamentally altered its structure. Rotational dynamics, particle ejection patterns, and spectral signatures all hinted at forces and interactions beyond standard models. Scientists began to speak of the event as a watershed moment, one that challenged assumptions about the behavior of interstellar objects and the apparent emptiness of the cosmos. It was not merely a passing phenomenon, but a glimpse into processes that operate on scales and with precision humanity had never witnessed before. The massive object itself, now receding into the depths of interstellar space, left behind a lingering sense of wonder and unease. Its movements had been calculated, its influence precise, and yet entirely inscrutable. It had arrived without warning, interacted with 3I/Atlas in a manner that defied conventional physics, and departed with a quiet finality that underscored how little humanity truly understands the universe around it. For those who had observed the event, the sky no longer felt entirely static. Between the stars, there was motion, influence, and perhaps purpose. The encounter left an indelible mark on human understanding, a reminder that even in the cold, vast emptiness of space, forces operate beyond our comprehension, and that the universe remains a place of infinite mystery, waiting for those with the curiosity and the courage to witness it.